Hey everyone, welcome to night 7 of Lambda School's Introduction to Web Development course. I'm Diandra Ryan Moss. I have some construction going on in my yard, so if anyone can hear some saws, I apologize for that, but I think it's probably quiet enough that won't bother anyone. If anyone comes into shot with a saw and then I scream and disappear, please send the cops to Bisbee, Arizona to reclaim my body. But hopefully that won't happen either. Speaking of grimness, we have my favorite lesson tonight, which is the lesson where I get to talk about assassins. But the assassins aren't the important part of it. The important part is that we were talking about classes. Classes are a concept that really extend beyond JavaScript. They're a really important concept in object-oriented languages like C or Java. So if you are coming from a language like C or Java, tonight's lesson will look awfully familiar to you. And when you're thinking about classes in JavaScript or in any language, you really want to think of them as your way of creating essentially your customized type. So we've worked with all sorts of built-in types like strings and booleans and functions and arrays. But tonight we're going to be customizing our own JavaScript type and using it to store information about assassins. All right, so before we get into that, I want to talk to you a little bit about Lambda School. As you know by now, because I keep telling you every single night, Lambda School is an online immersive for computer science and web development. So it's a 6-month full-time course where you, Monday through Friday, learn all about programming. So at the start, you're going to be more or less at the level you are now. You know a little bit about programming, you know a thing or two about how to write some JavaScript code or HTML code, but you're not necessarily at the point where you could actually go out and create an app, nor are you necessarily at the point where you'd be ready to jump into a programming job. We want to remedy that. So over the course of 6 months, we will teach you everything you need to know to be ready for a job in the programming field, specifically within web development. But the fun thing about programming is once you have a few skills under your belt, you learn more and more about, it's easier to learn more and more as you go. And that is really one of the fundamental pieces of being a programmer, is knowing how to learn. So, but that's kind of aside. The one thing I wanted to talk to you about in a little more detail tonight is our deferred tuition program. I have been mentioning this pretty much every night because it's pretty great, but I want to get into the nitty-gritty of how it works. The first thing I want to say is that it is actually optional. If you would prefer to pay your tuition up front, that is an option. The tuition up front is $20,000, just straight up that. And then once you're done, you don't have to pay Lambda anything else. So this might be a good option if you have that money available and if you suspect that you might get a really high-paying job out of Lambda School. You might actually end up saving money. But the option that most people go with is deferring tuition. You can either pay half your tuition up front and defer half, or you can pay nothing up front and defer the entire thing. So it ends up being a percentage of your first 2 years' salary. And I should have written down that percentage. I think it's 17%. Don't quote me on that. My bad for not knowing exactly that percentage. I'm sure the TAs can jump in and tell you exactly what that is. So, so the deferred tuition program means that you actually pay us back over the first 2 years on the job, and you pay a portion of your salary. So this will only go into effect if you are making $50K or more in a job in the programming field. So if you took the web development course but ended up working in AI or ended up working mobile, you still have to pay us tuition. If you end up deciding that you want to be a dental hygienist after Lambda School, we would be pretty bummed out, but you wouldn't actually owe us anything unless you're writing code while cleaning teeth, which would be kind of crazy. I don't think that job makes a lot of sense. But anyways, so yeah, you end up taking a percentage of your paycheck. So that means that if you, say, for example, choose to work for a startup, startups are really exciting, but one of the downsides is you might not have a huge paycheck, at least to start. You'd probably end up paying us a little less. If instead you went into the corporate sector and are writing code to make stock trades, you might be making a ton. And then you might end up paying Lambda a little more, but that's okay because you're making a bunch. Plus, we cap our tuition at $30K. So you'll never end up paying us more than $30K, no matter how awesome of a job you get after Lambda School. So that's a little bit more about how our deferred tuition program works. One thing I do have to mention is that there are some limitations to what we can offer our international students. So the paperwork on that ends up being a little hairy with some of our international students. So if you are an international student, the deferred tuition program might not be available to you, but please reach out to Karen Zachary. She can give you a better sense of what is and isn't available in terms of tuition. If you live in the United States, it is definitely available to you as long as you can get into Lambda School. On that note, if anyone is feeling ready for the admissions process for Lambda School, reach out to Karen and schedule a time for your interview, take the Lambda Challenge. Those are going to be the 2 steps you have to take to get into Lambda School. But enough about that. We have some code relating to assassins to write. Though before I share my screen and we start coding, I do want to talk to you a little bit about objects. So objects are something we learned last night, right? We explored arrays and objects, 2 data structures that are built into the language to help you store like data in an organized way. Arrays are great for lists. Objects are better for items that might require labeling. However, I didn't tell you something very important about objects. I'm sorry for withholding that information last night, but we're going to talk about it first thing today. So there's something very special about objects. They're not just another type in JavaScript. They're actually fundamental to how JavaScript works. So, and some of you guys, if you are paying really close attention, might have noticed that I actually have been using the word object since last week. I'll sometimes say things like, this JavaScript object, or if you declare a new JavaScript object, I kind of used it occasionally as more of an umbrella term. And there's a reason for that. So the thing that makes JavaScript objects special is that behind the scenes, everything is built out of objects. So all the data types, that includes Booleans, that includes strings, that includes numbers, functions, they're all built out of objects. It turns out that objects are kind of like the atom of programming. They're the building blocks that we build everything else out of. So the JavaScript developers, the people who created JavaScript, used objects to create all these other types. And they keep it pretty well hidden. They kind of abstract it out. So when you're using a string, it's really not obvious that it's secretly an object, but actually behind the scenes it is. So that's kind of a confusing and mind-boggling concept, especially to start, but it's also very exciting because now that we know that everything is just secretly an object behind the scenes, there's a lot of cool stuff we can use. Once we master that concept, the world of JavaScript will open up to us. And classes are part of that. So we're going to go in and take a look at how we can use JavaScript objects to create our own types. So I'm going to share my screen now. We'll do a little review of objects and how they work, and then we'll talk about building a class. All right. So up here, I have an object, an assassin object. Right now, we just have one assassin. So I call this the ghost assassin. Maybe we're writing this kind of code because we're in the process of designing a game and we need some code to keep track of all the assassins in this game. Or maybe we're a crime boss and we just need to keep track of our own literal assassins that we have employed. You guys decide. But either way, we have this object that represents a ghost assassin. So this thing has 4 keys. And of these keys, 3 are properties and 1 is a method. Can anyone in chat remind me of how do we tell the difference between just a regular old property versus a method? There's a pretty straightforward check, and it's good to keep track of which is which. So I see the parentheses. It's true that we need parentheses when we're calling a method, but there's an even deeper reason. It goes deeper than that. Why do we need the parentheses? has to do with the type of data we're storing. So a method is a function. And I see that you actually said a method has a function. It's even simpler than that. A method is a function. So this method is set equal to an anonymous function. So any key on your object that is a function is called a method. Just a little terminology reminder. And as we get into classes, we'll see that it's important we keep track of which properties are actually methods, because we'll handle them slightly different. But first of all, this is just a run-of-the-mill object. So we have a reminder of syntax, we have curly brackets, we have our property names or our keys, and then we use a colon and set them equal to a value. So the value is always going to be some JavaScript type. We see that there's quite a variety inside of this object. We have a string, a Boolean, a number, and a function. All of these are stored on this one Ghost Assassin object. So if I wanted to look up a particular item in here, I could do Ghost Assassin dot weapon. I'm using dot notation to look up the weapon value. And I just noticed that some of our code from last night was already on there. So I can look up the weapon value. I can look up the head count if I want. What is going to happen if I do Ghost Assassin dot kill? Just like this. If I run this code, what am I going to see appear over here? So we won't see, so one thing that was thrown out is that we might see that head count have been incremented. There we go. I got a lot of suggestions. I finally see the one I wanted. Function. We just see the keyword function. And this is, remember, because this is a method, we need to call it. It won't do anything until we call it. So you guys are absolutely right that we're going to see head count be incremented, but only after we throw the parentheses on. So if we do Ghost Assassin dot kill, and then we look inside of Ghost Assassin, we see that the head count has been incremented to 1. And if I were to copy this line of code and run kill multiple times, we see it's been incremented up to 3. And to briefly answer a question I see popping up in chat, dot notation is great for looking things up, but we can do more than look it up. If we wanted to change something, if we realized this was actually a very clumsy Ghost Assassin, we might change stealthy to false. So you can also use dot notation to reassign a value inside of your object. And keep in mind that even though this object was declared using const, we're still allowed to alter what's inside of it as long as we don't completely reassign it. So notice that I've used dot notation on line 12 to reassign one of my properties. So now when I look inside of my object, I see that stealthy is now set to false. So here's an object. Now let's create ourselves some more assassins, because the only thing better than one assassin is like 3 or 5 or 100. So can anyone, I will be accepting suggestions from the crowd. What types of assassins should we create tonight? What are some other assassins we should add to our army up here? Ninja, nice. One of my go-tos. Any other ideas? Pirate, also nice. All right, so yeah, of course, if we have a ninja, we have to have a pirate. Otherwise, it wouldn't be fair. Drop bear, I actually thought about doing a drop bear one earlier. I might have to go with that. All right, weapon for a ninja assassin is going to be, stealthy is definitely true. Head count 0. And I'm always going to start the head count at 0. And then as they kill, it will be incremented. All right, let's go ahead. Let's create ourselves a pirate. Pirate weapon is, what should our pirate's weapon be? Like a cannon? Is that, I always forget which one's cannon as in the weapon and which one's cannon as in like this is, or a cutlass. Let's do cutlass since apparently I can't remember how to spell cannon. Blunderbuss, yes, that is the weapon. Blunderbuss, pirates not very stealthy. They're often singing and swearing. And then let's do a drop bear assassin. And to save myself some hassle, I'm actually going to take out assassin from the names of all of these. I will thank myself later for that. Okay, we have drop bear. Weapon is sharp teeth. They're very stealthy, and there we go. So, and claws. Cool. So if we console log all of our assassins, and remember, I have to console log if I want to see all of them, because with code resolution, we can only see the very last one. And ghost. This is a good selection of assassins we've got tonight. Whoop. Change that one as well. Cool, so there they are, all of our assassins. And I bet you can guess what I'm about to say next. I, in fact, already see a Brandy is thrown out. Is there a way to group them and call them all at once? So that's essentially what we're doing tonight, right? So why don't we like this code? Why is it that we dry? Yes, it is not dry, it is wet. What did we decide that wet code stood for again last night? There was a really brilliant acronym someone came up with. Waste everyone's time. I don't write everything twice, waste everyone's time. I love it. You guys are really the best. I was like talking about drop bears with my boyfriend last night. I was like, do you know what drop bears are? And he's like, yeah, everyone knows. And I was like, ugh. But anyways, thank you guys for teaching me about drop bears. So anyways, yeah, so this is not dry, right? This is really repetitive. This head count and kill function are literally the same every time. And the properties are the same. There's a pattern here. So instead of just copying and pasting like I did, we want to, so it's not exactly that we want to make an object that consists of objects. We want to create a generator. We basically want to create a machine that spits out assassins. And so it's going to look a lot like a function. It's slightly different. It's called a constructor. And so a class includes a constructor, which is basically a function that just spits out new copies of this type. So we can create assassins really easily. And that's what we're about to do. Because who doesn't want to create assassins really easily? So I'm going to comment out this horrible not dry code, not delete it, comment it out, and then I will create us a constructor. So the first step to creating a class, really this is actually technically, once you create a constructor, you have created a class. So let's create our constructor. Oops, not Ninja. All right, does anyone notice anything slightly different about this? So I've started to create this constructor function. Does anyone see anything that looks a little different from the other functions we've created? It's capitalized, exactly. So it turns out that we can capitalize any function if we want, but this is another one of those cues to fellow developers. So remember last night how I said that arrays should be plural? It's not like your code would crash if your array name wasn't plural, but you want to stick to that pattern. The same thing is true when you're creating a constructor. You always want the name of your constructor, the name of your class, to be capitalized. So yeah, this thing is capitalized. And that tells us that it is actually a class. So now we know something extra about math and object and array and all these other capitalized variables we've seen. There's actually something a little more going on with them. It turns out that they're kind of like the thing we're about to create. And we'll talk about that at the end of the lesson, but I just wanted to point that out right now. So, and but even beyond being capitalized, there are a few things that are going to be different. So let me start out so the first thing you want to do is define all your property names. So we'll do this dot weapon, this dot stealthy, this dot head count. And for right now, we're going to actually skip the method. So we just put in the regular properties. And this is why I wanted to review the difference between a property and a method. Because methods we will handle a little differently. But we start by creating all the keys on our intended objects in this way. We just use the keyword this, and then use dot notation to create these. So for head count, right now we've created the key names, we've created the properties, but they're blank. So we can start out by just straight up hard coding in head count equals 0 because it's always going to start at 0. But for these two, we don't want to hard code in any value because the value might change depending on which assassin we're creating. So does anyone have a guess as to how we're going to set up these variables? We need we need to put values in them, but those values should change. So not quite. I'm getting a lot of interesting suggestions here. We could start them at null. We could start them at undefined. But there's something even better we can do. And a little hint is keep in mind that we are using a function here. So we can use, I see it, parameters. Yep, we can put parameters in. So just like a regular function, a constructor function takes in parameters for any values that might change depending on who's using it. So for these parameters, I'll put in weapon and stealthy. So notice it's a little confusing because my parameter name is the same as my property name. Just keep in mind that on the right side of the equal sign, that's referring to our parameter. And Replit will even give you a little hint with this pop-up. So this refers to this name. Over here, weapon just refers to the name of the property. So we could call these X and Y if we wanted. It would be maybe a little confusing, but it wouldn't matter. What really matters is that the thing we put on this actually has the exact name that we want our property to be called. And then let me assign in stealthy. Okay, cool. So we are actually done. We've just created a constructor function. Can anyone tell me anything else that is different from this function, from the regular functions that we're used to using? And I'll give you a little hint. There's something missing. There's something that we would normally want to put in our functions that I have left out here. A return statement, absolutely right. So it turns out that constructor functions do not require a return statement. When we call this, it will actually return an object. It will return an assassin object, even though we haven't called a return statement. And I'll talk to you in just a minute about why and how that works. So, okay, so keep in mind a constructor, this is not a particular assassin. This is like a mold. It's like a template. So yeah, if we think about this like, you know, creating a mold for a statue, the mold is actually empty. There's no statue in it, but we could use it to create a bunch of different statues out of different materials. That's what this thing is like. It's kind of like the master list for all assassins. So when we actually create the specific objects, those are called instances. So when we go and we create a new version of our ghost, it'll be an instance of assassin. Or if we create our ninja, it's an instance of assassin. So let me go ahead and create those. Oops. Spirit magic and true. All right, I'm gonna ask you guys one more time. What have I done here that's different? What have you guys not seen before? What is particular? The keyword new. So calling assassin, calling this constructor function is very similar to calling a function in that you need the parentheses and you need to put in your arguments. But the difference is that we have to use the keyword new. It turns out that new is very intimately tied to the fact that we don't need a return value. So what happens is, let me comment these out for right now. What happens is that up here, behind the scenes, because we called the keyword new, we created an object called this, and then we returned this. So the stuff I'm putting in, comments is things that will happen automatically. So something is returned, but it happens automatically. So we don't need to write out return. So we can see that Ghost actually contains this object here. The console log worked. If we didn't use the keyword new, this would break. So when I leave out the keyword new, Ghost is undefined, which is exactly what we would expect if you have a function that doesn't return anything. So the new keyword is really important. If we leave it out, we're in trouble. So make sure you use the keyword new whenever you're creating an instance of a class. So let's go ahead and create our other assassins. And I recognize I still haven't put our kill function on. I promise I will get to that soon. Pirates. And the last one is our drop bear. What was his weapon again? Sharp teeth and claws. And true. Okay, so let's bring these back in. And we have created all of them successfully. So why is this? I mean, it should be obvious that this is way better than how we did it before, but can anyone throw out some reasons why using a class was a way better approach? And don't just say dry. I know it's dry. We want to get more specific. What are some specific, concrete ways that this is better than this is better than all these? It uses less memory, absolutely. It saves space on the screen. Yeah, less lines of code. It can be automated. It would be easy to add more properties. Okay, great. I'm glad you said that. So if we want to change the properties or add properties, we can do that in one place. If I wanted to change this to kill count instead of head count, I would do that in one place and I'm good to go instead of having to change it 4 times. If I wanted to add a new property, like codename, I would still have to add it into all of these things, but it would be way easier than if I were trying to add them to all the individual objects. And there's also the final, it looks cleaner. The final thing is that we can actually tell. I won't get into it, but we can actually check using JavaScript that these are all instances of the same class. So once again, it's easy from a human perspective to recognize that these objects are related, but now there's a way in memory that connects, that says that these are all the same type. They're all, I mean, technically they're all objects, but they're all part of the same class. And yeah, if we were to add a new property in here, like let's hard code something in, this dot deadly equals true. That's always going to be the case. Deadly was just added to all of these. So it's a little more complicated if we want to add a new property that's variable, that's going to change. But if we want to hard code in a property, we just do that in one line and it changes on all of them. Even if there were 1,000 assassins, we would still have to only change it in one place. So we like classes. Classes are a good choice. All right. So one thing I wanted to note before I moved on is that there are actually a few different ways, just from a syntax perspective, there are a few different ways to create classes using JavaScript. It turns out that the way I've showed you here is not necessarily the easiest. ES6 was an update to JavaScript that came out about 3 years ago. It included const and let, which, as you know, I am a big fan of. Another thing that it included was a really easy way to create classes. So it turns out that in the main curriculum and probably in your career, you will be creating classes in a slightly different way than what I've done here. But there is a reason why I'm teaching you this way. The reason is that this way, what I'm doing here makes it really obvious what's going on behind the scenes. So I'm teaching you this technique for creating classes because I want you to understand what classes are and how they work. So if any of you guys know about ES6 classes and you're scratching your heads about why this looks different, or if you're Googling tonight for your homework and you see something else, understand this is only one way to do it. It's just my favorite way to start you guys off, because then when you move on to ES6 classes, you'll understand them a lot better. So just a little side note there. Now let's move on and talk about our kill method. So our kill method is really critical, right? These are totally wimpy assassins right now because they can't kill anyone. So let's add it on. So I'm going to start you off with a what not to do example. So it seems like we could just put kill here, right? And we could do this dot head count plus plus, right? I've created my other properties in this way. Why can't I create my method? It turns out that you can. This works. And if we called kill on, let's have our ghost kill a few people. Oops, kill. Let's have our drop bear. Our drop bear is obviously the most deadly of all our assassins. So we'll have him kill a bunch of people. Sorry, Ninja, you're not doing so well. I was always more of a pirate person on the pirate versus ninja debate. So I've called kill on these guys. The head count's incremented. So this works. This is allowed. It's syntactically correct. It works the way you think, but it's actually not the best way to do it. And the reason is memory. So let me break down what exactly happens here. So when I call line 52, when I create my ghost instance, this code runs and a new function is declared, right? Whenever we use the function keyword, a new function is declared. So all this code runs, a brand new function is created, and it's stored in memory. On line 53, all of this code is run when we create our ninja, and a brand new function is created and stored in memory. On line 54, the code is run, a brand new function is created and stored in memory. On line 55, the constructor is run and a brand new function is created in memory. So do you guys see the pattern? Do you guys see why this is not ideal? It turns out that we now have 4 exact copies of the same function living in memory. So now imagine that we worked at Facebook, and and this will give you a little insight into how this might be used behind the scenes. I bet you anything that for every Facebook user, there is a user class. I bet in Facebook's code base, there is a user class somewhere. And I bet that class has methods like friend request or like or message, post, etc. So imagine a brand new copy of each of, and those methods are probably a little more complicated than our kill method. So those methods if those methods were duplicated every time someone joined Facebook, that would be a massive waste of memory. And I see someone throwing out the suggestion that we create this in global scope. Nice use of scope. I love that you're bringing in scope. That's not exactly the issue though. The issue is that we're just creating a ton of copies. So we want one master copy that everyone can use because the function is exactly the same, right? So instead of creating a brand new copy every time, we want one master copy that everyone can use. And there is a way within this system where we can do that. So this whole class business is actually designed so that we can create master copies of all of our methods. And it's called the prototype. So the prototype lives on our assassin. So if we console log assassin.prototype, run this. Oops. Oh, now I'm getting errors. Let's comment this out for right now. So when I run this, I see an empty object here. So assassin has a property called prototype that to start out is just an empty object. And there's a little bit of subtlety here, right? Because keep in mind that weapon, stealthy, head count, these are all properties on the instances. So these properties we've defined up here live on the instances of this class. Prototype lives on the constructor. So that's our first clue that the prototype is kind of this meta concept. It's something that's going to apply to all of the instances. So this empty object on our constructor or on our assassin variable is going to be a storehouse for all methods. So we need to put our methods on this prototype. And then we do this dot head count plus plus. And then let me copy these in, confirm that it worked. Awesome. So our kill is working again. Even though I just wrote a couple lines of code, something really complex just happened. So I'm going to spend a while breaking it down. The first thing I want to talk about is the syntax. So assassin has a property. Assassin is an object. Remember, you're like, wait, it's a function. Okay, so let's back up. How is it possible that assassin, even though I've set it equal to a function, is also an object that can have a prototype? How is that possible? Does anyone want to try and explain that weird inconsistency? Assassin seems to be a function, yet it has a property called prototype. Any ideas, or are you guys stumped? And it's not the capitalization. It turns out this would be, even if I lowercase this, everything would work the same. Remember what I said at the very beginning of class? It has to do with that. All right, I'll stop torturing you and just let you know. So everything is secretly an object, remember? Even a function is an object. Yeah, exactly. So, so it turns out that we can actually put properties on really anything we want. We want to be intentional about how we do that. If we start putting properties on things that shouldn't have properties, we might get in trouble. But even though assassin is a function, it's also behind the scenes an object. So it can have a prototype. So the assassin, which is a function but also an object, has a prototype property. And prototype is just a regular old object. And then we can assign a kill property on it. So we're chaining. We're actually chaining properties. And then we just set it equal to our regular old anonymous function. All right, so that's the first weird thing that just happened. And hopefully that one is more or less cleared up. The second weird thing that happened is look at these objects. They don't have a kill function. How is it that I am killing even though when we literally look inside of our instances, we don't see a kill function anywhere? That seems awfully mysterious. And it is mysterious. So I don't think there's any way you guys would understand how this works without just knowing. So the prototype is a very special object because things are set up that whenever we call a method on an instance, the first place it will look is for a kill method within here. So if I were to actually hard code in a kill method, let's have this do something different. It's just going to console log kill. So notice that now that I've hard coded in a kill method, this is the one that's running. See, it's just logging kill, but the head count never increments. So whenever we call a method, the first place it will check is literally on the object, does this method exist? But if it doesn't, like in this case, it won't just give up. It won't say, oh, method is not defined. It will check somewhere else. It will check the prototype as a backup. So the first place it checks is in the object itself. If it can't find the method, it then defaults to the prototype. So in that way, we're able to use a communal method like kill. So that's just something that was set up intentionally to save memory. So that's how it works. As long as there's no kill method inside of the literal object, it will always check the prototype for a backup. If there's no kill method on the prototype, then it will throw an error. So this error, ghost.kill is not a function, will be thrown only if there is both no kill function in the method and no kill function in the prototype. So that's the next mysterious thing that's going on here. So the final strange thing is, notice that when I call ghost.kill, ghost's head count property goes up. When I call dropbear.kill, dropbear's head count property goes up. How does this function know which head count property to increment? And once again, this is a little tricky if anyone wants to venture a guess. How does this function know which kill function to increment? Absolutely, this. That is the magic of the this keyword. The way I like to describe this is, you know, when you go to the carnival and there's some ridiculous mural of like a strong man and a bearded lady, but their faces are missing. So you and your friends can go and stick your faces in and get a picture. That's what the keyword this is like. It's a placeholder. So any instance can stick its face in and actually assume the identity. So this is a placeholder, and whatever object we call kill on, it will be swapped out when we actually run this. And it turns out that this is a really confusing thing. I honestly think that the most hellish day when I was going through my own coding immersive was this day that I was trying to create a program where like lights were, like little dots on screen were blinking, and you had to use the this keyword a bunch, and I was like almost had a meltdown. So if you're ever struggling with this, just think of me trying to create blinky dots on my screen and having a meltdown over this. And then when I worked for that same coding boot camp and I had to teach that same day, I was like extremely hungover and I had to relive it all over again because I was exhausted and not in any position to be helping anyone work on that code. But that's a total tangent. At this point, I have used this enough that I feel confident I have mastered it, but it's tricky. So the simple rule for understanding this is whatever comes before the dots, that's what we'll replace this with. So there you go. And there is no that, but that is actually a really, if we're worried that this might change because this is tricky, sometimes you'll see that equals this, and it's kind of this weird technique for keeping track of what this refers to. The example I have up here is a little too simple to give you guys the full insight into how confusing this can really be. But you might end up using the that equals this trick at some point. It's very useful. So there is no keyword that though. All right, so now we know how to add a method in a way that is memory efficient, and hopefully we understand why this works, why we are allowed to put the kill on the prototype and still have it work for all of our instances. Yes, it does get more confusing than this. Hate to break it to you. So we've done it. We have successfully created a actually pretty sophisticated new class. We've created our constructor where we define all our properties and define whatever parameters our user should put in. We've defined what our method should be, and we can put as many methods as we want. If we wanted something called mega kill, mega kill adds 10 to the kill count. Whatever we wanted to add, we could add as many methods as we wanted onto the prototype. And then we create our instances. Very similar to calling a regular function, we use our parentheses, we put in our arguments, just make sure we have our keyword, new. If we don't use new, these will all be undefined. And then we can use these. We can call our methods, we can log them, we can reassign properties, whatever we want. So that is how you use a class. But there's more. Now that we understand how classes work, we actually have some pretty cool insight into what's going on behind the scenes in JavaScript. So the last thing I'm going to do with you guys is take the knowledge we've learned and use it to kind of hack into the JavaScript code and do some cool stuff. All right, so I'm going to get rid of, actually I'll just comment this out. We might want this code up for questions. So I'll comment out my console logs and go to the top here and do some fun stuff. So remember I mentioned that there is an object, there is an array object, there is a string object, and so forth. There's a Boolean object. Every data type we have, there is actually an object for it. So here's a little quiz. We'll just stick with the drop bear. So when I do, let me console log this. So when I run this code, when I call animal.toUpperCase, using what we just learned about prototypes, can anyone give me some insight into what's happening behind the scenes when I call animal.toUpperCase? And this is a really open-ended question, so there's lots of ways you can answer this. But using what we just learned about the prototype, what is happening when I call animal.toUpperCase in this example here? Any ideas? Yep, so here's maybe a simpler question, is that does animal really have a to uppercase property on it? And the answer is no. So the to uppercase property actually lives on the prototype. And I see someone is bringing up ES6 versus ES5 classes. So, and if you don't know anything about ES6 classes, feel free to ignore what I'm about to say. ES6 classes actually do use the prototype. They just hide the fact that they're using the prototype. So that's why I don't like to teach them to start, because they mask the prototype. So it turns out that behind the scenes, ES6 classes do in fact use the prototype. It's just not completely obvious that that's what they're doing. So it turns out that to uppercase, I mean, first of all, we now know, how is it that a string can even have a method on it? Well, because a string is secretly also an object. The other thing we know is that to uppercase actually lives on string with a capital S. And we can even confirm that. Unfortunately, Replit likes to hide things from us, but if we go over to the console, I know it's small, make your screen full size. We can, actually, we don't even need to console log in here. We could do string.prototype. And we can see all of the string methods. And we can even find it, so to uppercase, right here. So to uppercase actually lives on the prototype of string. That's where it really exists. So when we call animal.toUppercase, first it's going to check to see if there is a toUppercase method on animal. If it doesn't find it, it's then going to check to see if it's on string. So if we did, I'm actually not sure if this will work or not. I don't think I've ever tried this before. All right, I'm experimenting here. Ah, darn, it doesn't let me overwrite it. So sometimes you can do fun stuff like this. It doesn't want me to overwrite this though, sadly. Okay, but we can do something else. So let's actually go string dot to uppercase. Oops, string dot prototype. I'm gonna get rid of these other things. Set this equal to, copy and pasting fail. Sorry guys. There we go. Nice. So what have I just done here? I just went into, now that I know where to uppercase really lives, I went into string prototype and I overwrote it with a new function. I broke it, exactly. So you can break JavaScript now. This is always dangerous that I teach you this, but you now have the power to break JavaScript. One of the ways you can do that is overwriting commonly used functions with things that don't quite work. So now I'm getting error can't uppercase when I try to do to uppercase. So don't actually do this. A really good way to make everyone hate you would be to go into your, once you're hired, or even at Lambda school, go into your code base and start to change core functions. But yeah, so the global objects are not fixed. Remember that objects can be constant, but the properties are designed to be changed. So we can use that knowledge to actually change some pretty important stuff in JavaScript. Not what we want to do, but really good to know that we can. And so that's what's really fun about programming, is once you know the rules, you can break the rules in all sorts of fun ways. So we can do that. Is there any other fun stuff we want to do? I mean, really the thing I want you guys to keep in mind is that this string is, and actually, let's do string.prototype.